The death of the token. Generating text one word at a time is a computational dead end that we have finally outgrown. For over a decade, large language models have functioned as glorified autocomplete engines, guessing the very next token based on the sequence before it. But on May 7, 2026, ByteDance Seed released Cola DLM, proving we can now map an entire thought in a fluid mathematical space before a single word is ever written. This transition from autoregressive guessing to continuous latent diffusion is the most significant structural pivot since the original transformer. It signals the end of the sequential bottleneck that has made AI generation both slow and semantically shallow. The era of the chatbot as a predictive typist is over, replaced by a system that plans ideas before it chooses words. Liquifying the dictionary. The transition starts by treating language as a continuous semantic fluid rather than a string of distinct beads. Standard models are forced to commit to a specific word immediately, which often leads them into logical corners they cannot escape. Cola DLM uses a text VAE to compress discrete vocabulary into a stable, continuous latent space. Think of it as turning a bucket of gravel into a pool of water. In this state, the AI handles concepts as fluid coordinates rather than rigid labels. This allows the model to manipulate the overarching meaning of a paragraph without getting distracted by grammar or spelling in the early stages of thought. By decoupling the idea from the ink, the system maintains a global perspective that previous architectures lost the moment they started a sentence. This fluid foundation is what allows for the next step, modeling the actual evolution of a thought. Planning in parallel. Conventional models are trapped in a left-to-right straitjacket, where every new word is a prisoner of the words that came before it. Cola DLM breaks this sequence using a block-causal diffusion transformer. Instead of predicting the next token, it uses flow matching to transport a field of random noise toward a structured semantic goal across entire blocks of text simultaneously. This mechanism allows the model to refine the beginning, middle, and end of a response at the same time. It is the difference between a painter working through a straw and a photographer developing a whole print in a chemical bath. By processing these latent blocks in parallel, the architecture reduces the total number of sequential steps required to generate a long-form response. This does more than just save time. It ensures that the logical conclusion of an argument is planned before the opening sentence is even finalized. This structural foresight is why the model is already showing superior performance on reasoning tasks that require a holistic understanding of the prompt. The bottleneck of sequential decoding is no longer a physical requirement of intelligence. Why your benchmarks are broken. This architectural shift makes perplexity a useless metric for measuring intelligence. For years, we judged models by how well they predicted the next token in a sequence. But because Cola DLM operates in a continuous latent space, those traditional likelihood scores no longer correlate with actual quality. Recent data from the May 2026 benchmark shows that, while this model might look worse on paper using old math, its performance on reasoning-intensive tasks like MMLU and story close is surging. The scaling curves are the real proof. As researchers push the model toward 2,000 EFLOPs of compute, the upward trajectory remained remarkably steady compared to the plateauing performance of standard autoregressive baselines. We are moving toward a world where we judge AI by its ability to navigate a conceptual map, not its ability to guess a word. The old measuring sticks are failing because the nature of the machine has changed. The signal under the noise. The emergence of Cola DLM represents a fundamental mind-mouth split that will redefine how we build AI agents throughout the rest of 2026. By separating high-level semantic planning in the latent space from local textual realization, we are finally moving past the limitations of the transformer-based autocomplete. This shift, evidenced by the performance gains in story close and the scaling data seen in recent ByteDance Seed reports, proves that intelligence scales better when it is not forced to think and speak in the same breath. For engineers and strategists, this means the focus shifts from token efficiency to latent density. We are seeing a concrete path toward a unified generative architecture, where text and images are handled by the same diffusion backbone because they finally speak the same mathematical language of continuous vectors. This is the death of the multimodal patch job. Expect the first wave of these continuous latent backbones to hit consumer-grade agents by late 2026, effectively ending the era of the hallucinating word guesser. Watch for the first major open-weight release of a 10 billion parameter Cola variant as the sign that the industry has fully pivoted. Subscribe for more.